It's not every day that such an incredibly rare piece of history comes across your bench. This is a Stihl BLK from 1965, and it was a military saw. It was imported from Germany just recently. The owner said that he could just about get it to sputter very occasionally, but never run properly. So in today's video, I'm really excited to bring you along, find out what's wrong with it, see if we can save it. Parts for this are literally non-existent. And find out a little bit more about such an incredibly rare piece of history. It's 100cc, just under, 4,000 maximum RPM. As a point of reference, modern chainsaws idle at just a little bit below that. Maximum RPM is normally around 13,000. Isn't that incredible? Gear driven, doesn't give us much. That's kind of where I am at the moment. So we really are going in, you type it in, it doesn't even show the saw. Okay, let's get into it. So I want to take a look inside the cylinder, see what the condition is like first. Plugs are original Bosch. They then were made in Brazil and then finally made in China. We'll start with this borescope. Many of you have already seen it in use before, but if you haven't, there's links in the description below to it for you. It's absolutely incredible. Ooh, that looks like pitting to me. Not ideal. Piston crown looks good though. Not sure about that dent. Let's get on to do a compression test because I fear that is going to be one of our major issues. I use the MightyVac compression tester, and you've just got to be aware, whatever compression tester you get, that you've got a Schrader valve inside the adapter that goes into the cylinder head, and also that it's a low pressure one. Again, there are links in the description to this one if you want to grab one. Take your guesses. I'm not hopeful, I'll be completely honest with you. We need to make sure that it's grounded, that the switch is off, because otherwise you can actually damage the coil. There is the on-off switch on this. I'll take a guess and say that it's that, but that could also be a release for this front handle to be able to turn it 90 degrees. Let's get a spark tester on it and see what happens. And just in case the coil is failing, I don't want it to struggle to jump the gap. We'll bring it fairly close to give it every chance possible. Absolutely nothing. Let's just see if we'll get spark jumping across just the plug. The gap is tiny, so. Yeah, definitely getting it, but it's super, super weak. Right, now I'm going to hold down the button. Yeah, that's exactly what that is. 150 is ideal. There's absolutely no doubt in my mind that we haven't got 150. I mean, I could be wrong. Let's have a look. So we must ground. Oh, it's 115, it's borderline. I wouldn't be surprised if this wouldn't start just because of that. The cards certainly aren't being stacked in our favour at the moment, but we will hope for the best. I can't resist it. Oh. No, I genuinely feel like spark is currently our issue. Not that compression's great, but I've got a feeling. Let's dig into the ignition system. There's a saying that we all joke about, that it's never the spark plug. Well, it's always worth testing. This is a non-resistor plug. It's a W175T1. A non-resistor plug should basically show zero resistance between the center electrode and this threaded portion. Now, there is a little bit of oil on there, so it might be a little bit higher, but that's good. So here to here should show very little. Yeah, 0.2 ohms of resistance, 0.1, 0.2. That's perfectly good. So the HT lead looks like it's going behind this cover. It's held in place with some flathead screws. Some are missing, like here, so we do have to be aware of that. I'm not expecting this cover to come off easily. It's actually got some alignment pins, I've noticed. And of course the corrosion too. Oh, a bearing? It's a bit random. I have no idea. Here we go. Got it. Hey, look inside there. Does that remind you of something? I wonder whether it was an intentional addition to put a spare bearing in the air filter, so you've got it if you want on-the-go repairs. I reckon that's exactly what that is. That's crazy. If we can hold the slide open, we can take the tension off the throttle cable. So I'll just use a wooden lolly stick here. That will take the tension off the cable. Okay, there we go, we're disconnected. Not a good start. Put a little bit of heat on there. It's definitely coming. Let's do the other one. Got to do this so slowly and so carefully. Just put a piece of wood either side of a screwdriver so that we don't accidentally damage anything. If we gently prise. There we go. Okay. Perfect. And we're off. Would you believe it, right? You would assume, which is never a good thing to do, that if the cable's going into here and you've got the flywheel here, traditionally the points and condenser is always under the flywheel. Well, it's not. Well, it's certainly not a lost cause. There's a washer there. It's always good to see how things are put together. So I think we'll take that attachment off next. They give you a spare bearing so that if you're out in the field and one fails, you can replace it. Oh, how cool is that? That's so friggin' cool. Right, let's go make a cup of tea. I've got that compression in the back of my mind the whole time. Like spark, condenser, those things, there's many workarounds. Piston rings, cylinder walls, it gets a lot more expensive. But I think we're on the right track, at least starting with spark. We'll see how we go. I tell you, it still follows me absolutely everywhere. Check that out. This was given to me by my local steel shop. How cool is that? Okay. Put that to one side. Okay, got a little clip on here, we'll take that off. So I reckon that this threaded portion, the inside is part of the flywheel, And this outside threaded portion, which you loosen, must be your clutch. This is to take clutches off an 076. I reckon this will work just fine. We'll drill a couple of holes, put the pin in there, and then we'll just put a couple of drops of TIG weld on the back. Here. There we go, we got it. Okay, so what do we have? That's our clutch. This looks like, maybe this is a point. So, I still don't know why it's so loose. It just feels crazy loose to me. Anyway, we can probably carefully get a puller on this. Let's see how we go. Oh, there's no way they're going to fit in there. You can hit this crankshaft and gently prise up on it, but you don't want to. It's not good for anything. That said, a lot of manuals do say that, but in my opinion, this would have had a threaded puller. Something like this. Obviously, this is way too small, but that would go on, you'd thread it, and then you'd push it down. I certainly haven't got one of those. You see, yes, we can claim the points from here, but it doesn't allow you to test the coil, the capacitor. It all has to be taken out of a circuit. It's very hard to get this on camera, but they are clean. And the gap seems fine too. And we can't test the capacitor unless it's out of the circuit. And we can't get it out of the circuit unless we can get this top off. Doesn't seem to matter how I've got these jaws oriented. The spacing is just too wide. No, I don't like the feel of that. But it's as close as it is. I can't get a good pull on it. There's nothing I can get on here. Good morning, it's the next day. So I've been thinking about it and I've been putting off the inevitable. We need to make a custom puller for this to work. So let's go on with designing one and we'll get onto the lathe and do a bit of TIG welding to get this flywheel off. So I've done some digging around and I think we're going to use this coupling nut, and we've got this large bolt. It looks to be probably an M16, and I reckon if we can turn down a piece of steel, maybe even this one, I'll have to measure it. We need at least 32 mil, ideally 35. 33, so that will work. That looks way too small, 23. And this one will require a lot of turning, 56. So I think what we'll do, let's cut these, this will be a M32 by 1.5. Let's cut that into this piece of steel on the lathe. This coupling nut should easily, it fits really nice on that shaft. And then once we've turned those threads, if we TIG weld that together and we cut off this excess, drill a hole through it, we should have a nice custom puller. So let's get on with that now. So I've gone down about 0.98 mil, which is spec for these threads, and they look really lovely. So I'll chamfer the back and front now. We need to bore a hole for the shaft to fit through. We'll get on with some TIG welding. And now we've gone to 13 mil. I'm going to have to bore it out to 16. So let's get on with that now. So this thread's on. You want that to be fairly snug. It's fine. Next, our greased bolt goes in. Gosh! Let's give it a couple of taps with a hammer. You see, you're never going to be able to replace something like this if you crack it. Oh. Right, we're going to try some heat. Be very careful because of course we've got magnets in here and all the windings on the coil. Oh, I don't like it at all. It's making me feel sick. I want to go back in with the borescope. I just want to see, get an idea of the shaft and how much contact is in there. Okay, so there's the crankshaft. So okay, so and there, that is the top of the flywheel. So there's really, or the bottom of the flywheel. And it's not tapered. We can see the crank's not tapered. Right, I've had a bit of a thought. I can access that capacitor from this position. If I can heat it up and disconnect the primary wire, I can then test that capacitor, primary and secondary windings from that wire too, all without removing the flywheel. So I think that's what we'll do. Let's get the soldering iron on. There we go, okay. It's a bit low. Yeah, it's quite low. Not ideal. The manuals specify between 150 to 190, so we're low but we're not miles out. Let's charge the capacitor now, and we do that through the resistance setting. And we'll just run resistance through it, and it should start at 0, run its way up to around about 40, and then stop. Yeah, that's perfect. Now we'll make sure it discharges. We go on to voltage. And this isn't a polarizing capacitor, so it doesn't matter which prong goes where. And this should run down to 0, and it is. Yeah, that's working beautifully. I'm not convinced, it's not perfect, but I'm not convinced that's our issue. Let's test the primary winding. Should be about, say 1 ohm of resistance, but a bit less than that's perfectly acceptable. Yeah, there's nothing wrong with the primary. And now the secondary, we repeat the same process, but instead of touching ground, we actually go to the HT lead here. Yeah, nothing. That's not good. That is a short. Yeah, absolutely nothing. I'm going to sleep on it. I'm going to try again tomorrow morning. Oh, I don't like it. That's either my puller that's giving way or the part. I feel like we're going back to the drawing board. Yeah, I'm not sure what to do. I have to think about it a bit more. I was convinced today that it was going to be all right. I'll put anti-seize on the threads. Something's not right there. It's moved. Last time the key was visible and now it's recessed. Let's keep going. I think we got it. That feels so good to be inside. It is a pretty hefty flywheel, so I'm not that surprised. Let's test the magnets, because I was a bit concerned about those too. There's nothing special you have to do, you just need a piece of steel. Yeah, they're fairly unimpressive. Well, now we can take this coil out and I can disconnect the HT lead. There we go. That's our ignition coil. So before we take the stator off, which we're going to have to inevitably do, I'm going to just give myself some timing marks so that when I reassemble it, it saves me from having to manually time it. We'll just test the points, make sure that they have low resistance and that they do break cleanly. Should be nothing. Yeah, absolutely nothing. Break, return, straight back down. Yeah, no, they're good. Okay, and they don't look worn either. So we know that this coil is bad, and the customer who owns this machine had an 090, and while we were on the phone together I had him test it out and measure the distance between the mounting screws, and it should work. Ready? Yes. Ah, that's awesome. There we go. Carburettor's off. So we've got a flathead and a 10mm. So now we know we've got good spark, we can do a pressure and vacuum test. Now of course I don't have a block off plate for this machine, so we'll just see what we can do. Just a really important note with any gaskets on these older machines, cylinder base gaskets, exhaust gaskets, firewall material, it's highly likely to have asbestos in it. In this case I'm going to put a little bit of fuel on there in case it does release asbestos particles if I break it by accident. That fuel would just help to stop them from being in the air. The exhaust side gets a little piece of rubber inner tube to block it off. I've got a selection of bungs that came with the Mighty Vac, but the biggest one I got, which is this yellowy green colour, is way too small. The only thing I could potentially do, that one might work. Yeah, let's leave that there. That's it. I have a feeling that we're going to have to use the air compressor. I think it's going to leak that much. I could be wrong. Okay, it's already leaking. I tell you what, I'm not going to keep pumping. Let's get the compressor on it. Okay, so we're at 10 psi. Spark plug's good. The exhaust looks like it's sealing. Yep, that's good too. Let's check our intake side of things. Okay, so we have a leak at this fitting here. Let's fix that. We should have our reed valve Yeah, we've got a gasket on top, which is probably the issue, or this is just warped. I reckon just a little bit of sealant over that, just a tiny amount. So they've used some sort of plastic for the reeds themselves, which is interesting. I would have assumed it would be metal. But anyway, we could either cut out some new gaskets, or we could just put a drop of sealant on. Yeah, and of course down there, going straight into our bottom end. And of course this is our reed cover / intake mount for the carburettor. And if we look really closely, it's all cracked. Just put a little bead of Durco sealant on here, and then we'll re-pressure test it a little bit later once it's cured, and then we'll see if we can find a leak anywhere else. I think that will at least hold temporarily. Again, this could potentially be TIG welded. Maybe I could somehow then mount it up on the lathe and cut it back to true. None of it's ideal, especially being a cast piece like this. But let's try some Durco first. Least invasive. Well, we're not going to win any awards for elegance, but it doesn't matter. It's just a temporary fix. Proof of concept, just to make sure that we've dealt with at least one of the known air leaks. Okay. Put a little bit of fuel around that seal, and we'll just pull a vacuum and see if it sucks it up. No, that one's definitely leaking. Do you see that disappear then? So we've definitely got a PTO side leak. Yeah, we got it. Cool. And we've got this circlip here, and that's fine, but I'm just a bit concerned. There's a whole bunch of rollers that are held in place by this wire. So I just stuff it. Let's take it off. We'll probably, the floor's pretty tidy, so I'll be able to find things if I do drop something. Okay, that's off. All right, what is this? Does it come off in one? No. Yeah, look, it's all going to come out. It's just a standard starter, but all right, I can't lose them. 1, 2, 3, 4, 5, 6. Got a key. I can't get this side to fail, but I can't pull enough vacuum with the other one failing on me. So, even just wobbling it, yeah. Yeah, they're both failed. So the first thing we're going to do is take this little stator off, this cover off, and that will expose the bearings and the seals. So firstly we need to take the nut off of the points, and that will allow us to release the ground wire. And then that just leaves our HT lead. Take that off. Then we've got 4 M10s. Now there is a gasket under here, and I doubt this has ever been removed, so we might have to make one, and it might even take a gentle tap. Oh, the crankshaft comes apart. That's pretty cool. Now here's the big end bearing. I want to be careful taking it out. Don't want to lose any needles. No, they look captured. Just for ease later, I'm going to mark these parts. So when everything goes back, pink is showing up. Same thing again. There we go. So we have what's essentially crankcase and cylinder in one. You can take the cylinder head off on this, and maybe we will go in there and clean it up, especially as we've got it apart. But that's good, and our reference marks are going to help us later. Okay, let's get this nice and hot. Looking at around about 180 degrees or so. Flipping it over. Oh, didn't even need to be tapped. That's why heat is so useful. Now this side, we're going to repeat the same process. We have to ideally take this wire out. This is our grounding wire. Gentle tap. Oh, didn't even need it once again. Put this to one side. So I need to get this all sealed out this side, and I can't lever at least easily, and I can't punch from this way. I think by heating this up might give us enough expansion to then carefully prise it off. It's not wanting to come out. Maybe instead of using a slide hammer, I can carefully prise. I'll put this onto this side. No, it's not coming out at all. This is incredible. Okay, new hole. Nothing is working. I literally will just have to cut it out. This side I didn't go all the way through. This side I did, and of course the unfortunate reality is you do get a little bit of minor scratching in the bore. Fortunately, we have some incredible fuel resistant sealants that are perfect for these sorts of instances, just filling up those tiny minor imperfections in the bore. Of course, I'm going to gently go around with a little bit of Scotch-Brite abrasive just to take off the high points. Right, this side better be easier. And I think it will come from this way. There we go. Perfect. So the first thing we're going to have to make is replacement gaskets. I got this circle cutter. It's actually a really handy tool for gaskets. I'll put a link in the description below, along with all the other tools that I've used today. So we'll set it to 80. And now I'm just going to place that gasket on top for the location of the holes. Call it 6. Just to be safe, we'll go to 7. It's not going to get in the way. So that's 7 each side. So we're going to get 8.567. And of course we want to miss the edge of each of these holes. So we'll be close enough, but not right on top. Stop there. Stop there and reposition. Now just with a knife, very easy, or you could use scissors, we're going to finish off each one of these. So we've got a nice cut-out gasket. All right, that's our gasket. It should line up really nicely. Now, I just need to make a second one. Just whatever you guys do, don't tell the missus. But we've got parts to clean. It's really important to clean the crankshaft up too, including underneath these old bearings. So to pull those off, I've got a bearing puller kit. And again, there are links in the description below for you as well. And it's pretty simple. We're going to tighten on one of these pullers. Now, because the crankshaft is so long here, I'm going to put an extender on. Horizontal bracket. Nuts back on. And then I'm going to drive down this central threaded post and it'll help to pull that bearing up. Sometimes you need to give it a few taps on the side of the tool to get under that bearing. We'll see. Nope, that was lovely and easy. We'll repeat the same process, but just use a bigger housing. So this crank doesn't look too bad, and it could probably go straight back onto the machine. I'm going to give it a clean up anyway, of course. This is what we really want to clean up, this old burnt oil residue, especially if the seal is sitting anywhere near or on top of this. Not ideal. Let's go give that a clean too. So now we need to install our bearings, our seals and our crankshafts. The issue is, on some instances, like here, the seal has got to go underneath the bearing. So that means that although we can install the seal cold, which is correct, we can't install the bearing hot, otherwise we'll melt the seal. So we have to have a really methodical approach to this rebuild. And we're going to start with getting the large bearing, this is a 6204, into the case. Okay, this should now just fall in quite nicely. A little bit of a tap. And then we cool it right away with some air. So now this is actually quite warm. Sometimes, in this case is one of them, you can actually push the crankshaft all the way through if the bearing has a little bit of heat in it. Now the oil seal is next on this side. And it's cooled down enough where it's obviously not going to affect it. I'm going to clean that pocket of the oil because there's going to be oil from the bearing as I cooled it down. Just the cotton bud's really handy. I'm going to put a little bit of rubber grease on the inside lip and on the crankshaft too. And then lastly, a little bit of sealant on the outside lip. Again, links in the description. It's taken me ages to find sealants that I'm happy with. Now really carefully I'm going to move it over the cams for the points. The points run over, just to make sure we don't prolapse that seal. Now this is where things get tricky. Okay, so we have our pocket. Our seal has to go in from this side. It physically can't go in from that side. There's nowhere for it to go. It doesn't fit through there. But that means that we can't then heat it up to install the bearing on top of it. So then that also means, should I put the bearing onto the crankshaft? and put it in together, or should I put the bearing in on its own and then the crankshaft through? And of course, lastly, we have to protect the seal from this protruding lip here, because otherwise it's going to cause it to prolapse. Lots of things to think about. I think what we'll do, of course, the first thing has to be the seal install. Let's get on with that first. Same process as last time. If you can hear panting, you're the cause of it. Mwah. Say hello to the YouTube world. Now we've got to install this bearing cold, unfortunately, which means just pressing it through. Now, I will use some oil to help it go in. Unfortunately, there's not a lot more you can do about it. With that seal that's got to be put in before the bearing, it really does limit what we can and can't do. So I'm just lightly seating the bearing in its case, just making sure it's as square as I can get it before we start pressing. So that just leaves us installing the crankshaft on this side, bearing in mind we have to be careful with this lip. I'm not sure why that's there, but it is. So I think what I might do is get it part of the way over this lip, past the seal, and then we can focus on pressing it the rest of the way. We'll lubricate the shaft, we'll pop a small amount of cellophane over it, and I think we'll be okay. Okay, so that's out. So we've got our two gaskets. That one goes on there. And what we'll do is just put a drop of sealant on both sides. Just keeps things a little bit more secure, especially being such thin material that I had to go with. It's the OEM spec, but it's an old machine and things can warp and move a little bit. I've spoken about these paint markers before. They're so important. You could put that on this side and that on the other side and it'd be completely wrong. And in fact, without me having marked it, I'd have to go back through photos. That's fine, but not necessary in this case. The pink up here shows that that's facing up. The pink up here, on this part here, on the crankshaft, is also facing up. So I know that that one goes onto that side and this magneto side goes on the top. And I'm a bit of a perfectionist, to say the least. So I will just take that off now that we're finished. You can see it comes off really nice and easy. When it's baked on, when you've heated it up, it can be incredibly difficult to remove. So just keep that in mind. Same with this side. I know the pink's facing up and I can remove that nice and easily and it's served its purpose. Ready to rock and roll. I reckon that's going to be absolutely fine. Yeah, that's lovely. Just make sure that's nipped up. So now this wiper pad, I'm just going to put a tiny drop of oil on there, not too much. And the pivot point for the points, you pop a bit of grease on, but actually it's got grease on there. They feel smooth, and sometimes getting grease too close to the points themselves can cause more problems than it solves. So we can leave well alone with that drop of oil. Excuse fingers. Okay, now we can put the other case half on. In fact, just before we do, I'll just put a drop of oil on the cylinder wall and on the exposed bearings as well. Then our gasket. For anyone that's been around any small engine, you'll notice this style of carburettor. It's a float bar carburettor. It's what you'd find on your lawnmower. It's quite unique. It's not something you'd see on a chainsaw, because if it's turned on its side, which you need to do when you're taking down a tree, it'll actually flood the carburettor. There's a technique they've used on this saw to mitigate it, which I'll show you later. Oh, this is our float bowl gasket. So that needs to be replaced. That's the crispiest I've seen before. And then, yeah, just like a normal lawnmower, you've got a pilot circuit and you've got a main circuit. That's partially blocked. And then we have this emulsion tube, and this is basically where the fuel and air mix together before it goes in through the carburettor. And each one of these needs to be clear as well. Float and the needle will come out. We have got something a little bit unique here as well, although it was common for that era. It's called a tickler. It's this little pin here. For a cold start, instead of choking it, though we do still have a choke, this tickler pushes down on the float and it floods the carburettor and gives it more fuel. It's a really cool design, it's really simple, and it looks like if we remove this brass screw, we can take out that and just give it a little clean. And then we'll take off these two flatheads, although they look like they've been rounded off fairly badly. Ah, yeah, I don't know if that's going to be coming out. That feels so good. We got it. Before we can rebuild it, we need to figure out a float bowl gasket. And I've done some digging around, and neither one is ideal. That one is close-ish, but it's very thick in comparison to the original, about twice as thick. And here's another one. This one's brand new, and it's thinner than the original, probably about by a third, and it's too big. But I think we're going to use this, so we just have to make it fit. So we're nearly there. I'm going to just put the gearbox onto this crankshaft so that the clutch can engage. Just a little bit of grease on the lip. Now just a real small amount of grease between the gearbox and the power head. This collar, just so it can move smoothly. So with it locked down, the handle doesn't move. And I've adjusted it by the tension screw. Now you can rotate to cut 90 degrees. It's a bit tight, but it moves. Flooded. Ooh, it's 115, it's borderline. I wouldn't be surprised if this wouldn't start. I've got that compression in the back of my mind the whole time. Well, since I had that brief run for about 10 seconds, I haven't been able to get anything else out of it. And it's dropped even further on compression. We're now down to 110. Even at 115 at the beginning of the video, I was really concerned that it wasn't going to last. It wasn't going to run properly. And that's the reality of it, unfortunately. And the owner didn't want to put a new top end in there. And I understand that too. Anyway, if you've enjoyed this video, please consider subscribing. And also, there's so much going on that you don't see that I upload onto Patreon. So if you want to help the channel out, support it, then please head over there. I've put links in the description below for you. Until next time, catch you soon.